Good morning, this is Diana of Be4STEM, where we help you try and find the right STEM career for your future. We've really enjoyed this year and having 9 episodes to show you different careers. We've enjoyed traveling around to different places and meeting different people who do real STEM careers every day. Today's challenge that I sent you is one that I hope you will find fun and interesting. It's about using the engineering design process for building the best pet home of your dreams. So let's get started. I want to go back through all our episodes and review because in order to do our design project, what you're going to learn today is that it takes all the different STEM types working together. And with our career crew, we've tried to help you come through the year and learn about each of the different STEM types. And so we're going to go back over and meet them now. Okay, so let's get started. In month 1, we talked about the concept of measurement, and the STEM type that goes with measurement is Neil. He was our sample who we visited. Neil is a swimmer on a competitive local swim team, and he uses all the different types of measurement to achieve the best quality of swim he can because he wants to win a scholarship eventually. So his STEM type uses measurement to improve his swimming to compete better each year. And many careers use measurement to make our lives better, and this is an example of the tools we used in lesson 1. So in each month, I want you to go to YouTube and go back and find the lessons that we've posted up there of Neil and how we use these tools, and you can find out if these tools would work for you. So then in month 2, let's move that because in month 2, we had a different type of venture. We traveled to an interior design studio and met with Ginger at Chattahoochee College, where she teaches students how to use materials in the best way possible to furnish people's homes, businesses, outside surfaces like porches and decks, and get the most for their money. So in that type of career, Ginger teaches the latest complex patterns and textures created in many materials that are manufactured to choose the best products for each use. We used robotic arms in the lesson for Unit 2. So please go back and look at that lesson and see how you can separate all the different materials around us. Then in month 3, we went and visited Sherry Jackson at the Robotic Surgery Center at St. Joseph's Hospital in Atlanta. Sherry's role is to prepare and evaluate the best robotic surgery techniques to teach doctors to use the latest robotic machines in operating rooms. And what we used for that again were lessons with the robotic arms, but also how to use that and test for magnetism, because today magnetism is driving a lot of our surgery techniques, and sometimes even in processes to pull harmful cancer cells out of our body. So those were the lessons that we learned in Unit 3, and we did, if you recall, he's hiding from me right now, but we also used a tiny cup. And it looks like he might have jumped right off my plate right now, but I'll find him if I can when we come back. And then in Unit 4, we met Tommy and Caroline. Caroline did a video as an astronomy student to teach us all about how we study the universe. And she actually studies black holes in the universe. And then we went to an in-classroom planetarium at a local school in Atlanta. The lesson that we used in Unit 4, we used 3D sunglasses so that we can see how we can use materials to separate light because they come in different wavelengths. And this is one of the tools we used. Each star emits a certain wavelength of light back to Earth, and if we can measure that with a telescope, then we can find out all kinds of characteristics about that star. And look what showed up here. This is my tiny cup that I was trying to find from Unit 3, Forces, testing forces in nature. Do you remember that in this unit we tested the force of gravity and put water in the cup and it didn't come out? So you need to have a tiny cup. Go back and look at that unit if you have a chance and see our planetarium visit and Caroline's video too. We hope you'll enjoy that one. It uses a lot of math. Most of these careers use a lot of math. So if studying the solar system and the stars and the galaxies interests you, that's what you can do with that. In our next unit, we visited some labs that study nanotechnology equipment at Georgia Tech. And that means they're on the nanoscale. And at Georgia Tech, they're constantly studying the scale of things. So we, in that unit, use this technique, and magnetism is very important to all of this because some of their tools have to work on a vacuum technique, and then separating materials from largest, and then all the way down to the smallest one, which on this set is right here. And separating all of them out is what they have to do to find the very smallest scale materials to test in their equipment. And in those careers, Todd and David, who we met in videos explaining how their equipment works in labs, use science to make new discoveries in how materials can help us each day. And David especially told us about how we do research to make the thinnest Coke can, but with the strongest material possible. So his is very interesting indeed. And then from there, we went on the next month to learn about Peter. And what I've been able to do today is show you his videos at the end of our session. So if you can, after we learn about how to use the design process, hang on, because he's going to be showing up in how he does his career as an arborist and also how he teaches people to climb trees. In that lesson, we were able to design zoo habitats for animals and choose the best soil types for these animals. We had many different soil types and we tried to choose the best one for each of these animals and explain how they would best survive in their habitat. So that was a fun unit. And then from that one, we went on to Stephen. And Stephen, we visited a welding school where Stephen is an instructor to students who want to learn how to do welding as a career. And that's where we found the toolbox. So let's move on to the next unit, and we're almost up to seeing how all these different kinds of careers combine and are needed to do the best job in the engineering design process. Oh boy, I can't wait. Let's keep going. So if you think that a career in construction type trades, in a career where you might use a big toolbox like this would be for you, then you might want to do the same sort of job as Stephen, and you need to look at his video on YouTube and go back and do the lessons from Unit 7. In Unit 8, which was just 2 months ago, or last month actually, we met Charles, who is an entrepreneur who has his own business, and he used to be a project manager in engineering building projects. So he sort of had some of the training like Stephen in building, but mostly designing. And when we met him, he would be most like our character called Dennis, who works in a lab and tests things. And to see what that job would be like, testing materials, We tested some magic sand, and I hope you remember what that was like, because materials that have special coatings that are newly developed are more useful in the environment in some situations, and we can transfer that when we're building things. So keep that in mind when you're building your pet home. But this month, what we want to do is again talk about the engineering design process, and to do that, we're going to combine all those characters, and hopefully you'll work in a team, and you'll want to take some different materials and decide which pet you want to work with. So it might be a butterfly. That would be a butterfly garden. It might be a lion. He'd need a mountain environment, I think. Or it could be a duck, and he might need a pond. It could be a snake, and we need to find out what he would need to live in. Or it could be marine animals. So freshwater or deep ocean animals, marine animals, and whichever one you choose, I hope that you will enjoy following the directions and trying to build the safest house with the sturdiest roof possible. And let me know how your project comes out. So have a great summer, and we look forward to seeing you next year. Thanks for being with us.
Hi, my name's Matt Breitenthal. I'm a structural engineer. We're here at MercedesBenz Stadium for Be4STEM. Structural engineer is part of a design team with a lot of different disciplines. I don't know if you've heard of architects and contractors, but for any building like this, it takes thousands of people to make a reality. Architects typically come up with ideas and determine the aesthetics and the functions and how things will work. They'll engage engineers from certain disciplines, mine is structural, to come up with how we're going to make the structure, the steel, the concrete, the wood, the masonry, the building to hold everything up. You can see on a stadium like this, these are very long spans. Long spans for stadiums like this are a very special kind of design and construction. And Mercedes-Benz Stadium is a very special building. There's a lot of features about this stadium that have never been done before. You can see the big black circle in the background. It's more of an ellipse, but that's the largest video board in North America. I think also the largest video board in sports. That is 1,100 feet around. So if you cut that and then kind of unspooled it, it would be the tallest building in the city of Atlanta. It's also 65 feet this way, and so they get all sorts of really cool video displays going all the way around, and everyone in the stadium can see that. On top of that, right now the roof is closed, but there are 8 pedals at the top there that all open. And so you can open this roof in a matter of 10 or 20 minutes and have daylight coming in. So they have games here, open or closed roof. And those are some of the features here that don't exist in any other stadium. One of the tools that we use in the design of buildings is called 3D printing. And so physical modeling has been part of the architecture and engineering profession for a long time, but now we're able to do that in a lot more advanced ways. And so what I'm holding here is a 3D printed panel that supports the video halo board. And so you can see the entire ellipse there is made up of 26 of these, none of which are the same. They're all unique. And so in order to kind of communicate with other people how this system is going to work, we have structural models in the computer for this, but we also decided to 3D print these to show how, each one of these works. That this is called a truss, and it spans at the top from one side to the other and attaches to the rest of the roof. And then in the back, we've got these little sticks that hang out, and then we've got hangers that extend down the full length on the back. And then we have each of these little walkways. Those are about 12 feet apart, so about the height of a story of a building, and those are necessary so that maintenance people can get in there and fix the video boards and things like that. But they're also structural, and they work to restrain the whole system, and so that's how the system works. But we 3D printed it so that you can explain it to a non-technical audience. You know, one of the nice things about this stadium is that they can use it for different events, and so this is a great time to look at this because we have Atlanta Falcons games here, but also Atlanta United, which is soccer. So you can see that there's a banner up at the upper right that blocks off the top tier of seats, because usually you don't have as many people at a soccer game as you do at a football stadium. And so this design kind of accommodates that. And then you can see on the field, they just had a soccer game here a few nights ago, but then towards the back, they're setting this up for a concert in a little while. So a venue like this needs to operate for all sorts of different things. Up at the top, we've got the operable roof pedals. So those open and close for various kind of weather scenarios and things like that. And then we've got the video screen that wraps the entire length. That's 1,100 feet around. It's the largest of its kind easily in terms of size, and also elliptical. It's an unprecedented design feature. These, the roof steel here spans about 700 feet. And it spans onto these huge columns, and this one is actually a video board. That's an entire television wrapped around the column. And then one of the other features for the design is this window to the city. And so it's the only face of the building that looks like this, but the whole point is that the stadium welcomes the city, looks back at it, and so our office and a lot of people's offices are in the buildings behind this. And so during a game or when they're warming up, you can look right into the stadium and see what's happening. And then in the front is another feature here, is the Falcon sculpture, which is, again, I think is the largest of its kind in the world. It's a falcon on a football, and we'll walk out here. This is, I think, the largest sculpture of its kind in the world.
Jonathan Colebrook, and I'm a design engineer with HOK. We've got a couple more questions for you.
Sure.
What would a day at work include for you, and what different careers would you consider to be related to structural engineering?
Okay, those are good questions. One of the things I love about what we do as structural engineers is that no day is the same. There's days where we're spending a lot of time drawing and sketching and coming up with ideas. There's days where we're doing structural analysis. But I love that we have jobs that get built. And so we get to come to construction sites like this while it's getting built. I love having at least one job in construction, so you get out to the site and check it out. And so you get to see things from just little thumbnail sketches through to fully built over the life of the project. But then also, we've got multiple projects. We get to work on a lot of projects at the same time, which I really enjoy, because then you get to see those phases, and so you might get all that crammed into one day, which is a lot of fun. I like being able to bounce around those things. Some of the other jobs that impact structural engineering are architects. We work with architects a lot, and interior designers. And one thing I didn't realize before I got into the profession was how many different specialties of architects and designers and planners there are. There are people who design and plan entire cities, entire blocks, and then architects who specialize in stadiums or airports or hospitals, pretty much any building you can imagine. The thing I like about structural engineering is that we're able to work on a wider variety of those project types. So a structural engineer can work on a tower, or an airport, or a stadium, and that variety is really nice as opposed to hospitals all the time, because they're all really unique and interesting project types. So we get to work with those designers a lot. We also get to work with engineers of all sorts of other disciplines, mechanical, electrical, plumbing. I've had the benefit of working on airports a lot, and one of the things I like about airport projects is that on a usual standard building type, you might have 5 or 6 design disciplines, but on an airport you'll get 20 design disciplines. And so if you really are interested in other people and other jobs and how it impacts yours, airport projects are great like that. They're their own little cities. You know, people design the baggage systems, people design you know, the gate that goes out and meets the airplane, they design the paving, so those are really interesting projects. And so as a profession, as a structural engineer, one of the best things is you get to meet and work with all sorts of people who do things differently than you, but that impact you. And I've found that to the extent I've had success in my career, it's been because I've been able to explain structural engineering to non-structural engineers. Because the best answer is not within one discipline; it's, you know, us solving one big holistic solution. And it's a great career for someone who enjoys that.
What drove you to this career as you were growing up, and what you saw on a day-to-day basis?
Yeah, I grew up interning in my father's architectural firm. So I heard all sorts of bad things about engineers and then decided to become one. And then it's funny, I went into college for pre-medical engineering because they had the most scholarship money, you know, and then I went and visited a few of my friends in architectural studio, and it wasn't until then that it clicked, like, this just looks like a lot more fun. So I switched into the major after I got into college, and then once I was in it, I went to the University of Kansas for undergrad, and in that program, the architects and the engineers were all in the same studio. And I found during that and going through designs with friends that I liked the initial concepts that my friends did more than I liked my own, but I found I was really good at helping them once they had a concept, turn that into a really refined and developed design. And as I learned more and more about the opportunities within the building industry, I found that structural engineering really resonated with me. And so I kind of ran with that. I took a little bit of a break after graduating from college, and I did software coding for a little bit. And then decided I really missed building design. I was certain I wanted to get back into it, so I went and got a graduate degree, but I got to combine the software coding with that, and that's actually been really helpful. You know, software development and a knowledge of that kind of impacts all disciplines and all fields now, and having a working knowledge of that has helped quite a bit. So, for example, you know, the video halo board up there, we call it the halo, that's the big video screen, had to be designed really, really quickly, in a way that would have been impossible without the software tools that we have now. So I got into it not with a really planned linear path, but as seeing a lot of things, all of which have kind of impacted my career in different ways.
As a young budding engineer, what are some tips or qualities that you would suggest to help guide somebody into this career and be successful at it?
No, that's a great question. I would say the first thing is just to understand basically that there is no us and them. You know, everybody in all these other disciplines, you know, it's important to not be siloed and understand that an architect, you know, different disciplines need to work together to solve challenges and problems. And often there's, you know, 100 different ways of solving it, and people see it as a win-lose, which it really isn't. You know, there's a bunch of different ways, and usually you can come up with a solution that works for everybody, or works really well. So you need to be creative enough to do that, but I think even before that, everybody who's working together needs a level of trust. And in order to have that, you need to look at everybody as a person who's trying to achieve the same thing, as opposed to, I'm the engineer and that's the architect. And if you start from that, you'll never get to the levels you can achieve if you see everybody. I would encourage being creative and trying to do research into creative systems and seeing what you can bring to that. And then talking to as many people in these different disciplines as you can. And, you know, the first 2 or 3 years, 5 years, I mean, it even applies today, of my career, I was learning more than I knew what to do. Even today, I would say, you know, if I had all the time in the world, I could still just kind of digest everything all the time. That's one of the nice things about the field. Like, there's an encyclopedic amount that you have to learn. And so the first few years are just kind of, you have to see that to see what you like. And then after that, it's starting to see if you want to tailor it a certain way. And part of that is also just going to be opportunities.
Hello, this is Diana from Be4STEM, and today we are going to talk about living things in the environment with Peter Jenkins, who is a certified arborist and much more. But first he's going to tell us about the career of an arborist. So tell us, Peter, what is your particular role? How do you see your career?
So my career is working with trees that live around houses and people. That's called urban forestry. And the word arborist, arbor means tree, ist, that part means expert. So I'm a tree expert.
Oh man. All right. Urban forestry?
Yeah, that's trees that live around where people do.
I love that term. I hadn't heard that term before. So tell me, what tools do you use to collect the knowledge and information about the living things, including trees and what lives in them? As you can tell, we have birds in the background, and they're kind of taking breaks and then going, and now we have another bird joining us, which is an airplane going by. So this is fun for me. I hope it's fun for you. But tell us more about the tools you use in your job.
So when I go out and look at trees, what I'm looking for is the tree healthy or is the tree sick? Is the tree going to stay standing or is it going to fall down? And if it's going to fall down, you want to know when and take care of the problem before it falls down. So these are some of the tools that I use. This is called a soil probe. I use this to feel around underneath the soil to see where the roots are. So if I wanted to see where these roots are here, I push down in the ground. Yep, there's still more roots. This root here is coming out this way. And I can push this down and I can find out where the root's growing. If there's a cavity, like there's a hollow spot, I'll stick it inside the tree and feel around inside the tree, so now I get a good idea of how hollow is it. So that's what this is used for. Now I have a whole package of tools right here. This one's called a mallet. Can you guess what I do with this? I hit the tree, but I don't hurt the tree. I just hit it and I listen for the sound. So when I look at trees, I want to know, is the tree decayed or rotten, or is it good wood? So I'll knock, and I'll listen to the sound. If there's trees that have decayed or rotten parts, the sound will change, and it usually sounds like a bass drum. Boom, boom, boom. That's when I'll say, we need to look a little bit closer here because that just doesn't sound right. This tool right here is a simple screwdriver, but it's blunt, it's not sharp. So sometimes when I'm looking at a tree, if it has a part that's sort of like decayed or something, and I want to sort of get an idea how deep the decay is, I'll just push this in gently and lean into it. And if it goes in right here, if it goes in like this, then I can pull it out and I can say, oh, we got 2 inches of decay. And it's a very simple tool, but it gives me good information.
I think the birds are listening to you.
Yeah, they are.
Quiet.
The birds are listening. That's right. Okay, so this is a gardening tool, and it's you. If your mom and dad garden, you might have seen something like this. I use this to pull away leaves at the bottom of the tree, so that way if there's mushrooms and things growing right next to the tree, then I'll be able to see them, because usually the leaves fall down and they hide things, and I want to unhide them. Here's another simple gardening tool. Sometimes I use this to dig down next to the tree or the trunk, just to make sure there's no decayed area or rotten area below the ground, because I can't see it on top of the ground. So sometimes I dig down just a little bit just to see what's below the ground. Well, earthworms we want to see around trees, so there's always earthworms. There's always insects in the trees, and some insects are good for the tree, some insects are not good for the tree. So, but they're always around. What you don't want is too many insects of the bad kind. And that way, that can be bad for the tree. But all these creatures, all these insects and organisms, there's billions and billions of them. If I was to have a little handful of soil, there'd be probably maybe 10,000 microscopic microbes, little itty-bitty living things that we can't see unless we have a big microscope.
Well, all of this is fascinating, and it looks like you must have a lot of fun every day. But tell us, what is one of your favorite and most rewarding parts of this career?
One of the things I really like about being an arborist is climbing trees. And I bet you've climbed a tree before. You know how exciting it is. Guess what? When you grow up, you could be still excited by climbing trees, but we do our tree climbing with a rope and a saddle.
Wow. Well, we're going to take a break, but we're going to come back and talk a little bit more about tree climbing in a minute. See you. This is Diana of Be4STEM, and I promised we'd be back. But the last question that I wanted to ask Peter today was, what are some other careers that might be related to his career? And amazingly, he also does another career that's related to his, which is tree climbing. And he teaches tree climbing as another career. So I would like you to tell us, Peter, why do you do that and how is it helpful? And give us a demonstration.
Okay. All right. So why do we climb trees? Well, sometimes trees need to be pruned. They have dangerous dead branches over houses. Sometimes the whole tree needs to come down because it's dead. So there's lots of reasons to climb trees. And I'm going to show you how we do it very succinctly. Okay, the first thing that we do is we need to get our rope in the tree, because we climb trees with ropes. We don't free climb a tree. We always use a rope to climb a tree. That way, if we slip off the tree, the rope catches us and we don't fall. You don't want to fall. So these are what we call throw bags. This is the throw line. So I'm going to use this to throw up over a branch, because this is much lighter than a rope. So I can throw this much further than throwing a rope. So I throw this over the branch, get my rope, attach it to the throw line, pull it up and over. I'm going to tie some knots. Then I'm going to put my helmet on, and then I'm going to show you how we climb. Okay. I'm going to rock it back and forth, and right before I throw it, I'm going to yell, "Throwing!" That way people know that I'm throwing away. Throwing. Ooh, that was a good one. I think. And yay, there it is. There's my weight. Yay. There goes the rope. Okay, so the cambium saver slipped over the top of the branch. Now I'm going to pull and take the knot out. Now I'll pull the rope down. All right, so I got the end right here. I'm going to take the throw line off. I'm finished with the throw line. Now, I'm ready to climb. So this is how it works. I pull down on one side, push the knot up. Pull down on one side, push the knot up. So I'm going to sit down in my saddle, make sure it's comfortable. Yeah, comfortable. And this is how it works. Pull down, push the knot up. Pull down, push the knot up. Pull down, push the knot up. Okay, so let's say I'm at the top of the tree and I want to come down, all I have to do is I grab this rope first, just to make sure if I get going too fast, I can slow myself down. Put my hand on top of that knot and very, very slightly pull down. Very slowly. There we go. Pull down, slide down the rope, let go, the knot pulls you in place. Pull down the knot, let go, knot pulls you in place. And so that is how we go up and down the tree. If you like tree climbing, then you might want to think about, hey, I could keep climbing trees when I grow up. So there's something fun that you probably might already like that you could do when you get to be a big person, just like me. Okay, and that would be climbing a tree. And there are other areas that you can go into. You could be someone that looks for bad trees. I do that too. And that doesn't involve climbing. I could be a scientist, I could be in a laboratory, I could be a research person, you know, doing all kinds of tests on trees, trying to figure out what trees do and how they do it. There's all kinds of ways you can hang around trees and still be related to trees.
Well, we certainly enjoyed meeting you today, and thank you very much
Thank you.
for helping us.
It's been fun.
And we hope you enjoyed this day with an arborist, and we'll see you back in the lab. Bye for now.